For as long as we've looked to the stars, we've been telling ourselves a story of a beginning, a singular moment 13.8 billion years ago when everything we know, every star, every galaxy, every planet, burst forth from an infinitely hot, dense point. We call it the Big Bang. It's the opening line of our cosmic story, but what if it's not the real beginning? What if it's just a single chapter in a book so vast it has no beginning and no end? For decades, the story has been the same. Our universe began with the Big Bang, but what if that was just one moment in an endless cosmic saga? Observations from the James Webb Space Telescope are revealing galaxies from the dawn of time that are so massive and mature, they're challenging our most fundamental models of the early universe. These perplexing discoveries are breathing new life into a radical theory by Nobel laureate Roger Penrose that our universe is just one of many, and that we might be seeing clues from the one that came before. The standard model of cosmology is one of science's greatest triumphs. It tells a coherent story from the first moments of expansion to the grand cosmic web of galaxies we see today. The model predicted that the earliest galaxies should be small, chaotic, and metal-poor. In cosmology, metals are any elements heavier than hydrogen and helium. These elements are forged in the hearts of stars and scattered through space when they die. It takes generations of stars living and dying to enrich a galaxy with these materials. So, when the James Webb Space Telescope peered back to the dawn of time, scientists expected to see galactic infants. Instead, they were stunned. JWST started spotting galaxies that were far too bright, far too massive, and far too mature. They were nicknamed universe breakers because their very existence seemed to push our timeline to its limits. JWST has found galaxies that appear to be as massive as our own Milky Way at just 500 to 700 million years after the Big Bang. Finding something so developed in what was supposed to be the cosmic nursery is like finding an oak tree in a tray of freshly planted seeds. It just doesn't fit. While later analysis has suggested some of these galaxies might not be as massive as first thought, perhaps appearing brighter due to feeding supermassive black holes or gravitational lensing, the puzzle hasn't disappeared. We're still seeing more galaxies than our models predict. In early 2026, astronomers using both JWST and the ALMA Observatory confirmed a population of 70 faint, dusty galaxies from less than a billion years after the Big Bang. The shocking part? They were already rich in metals, suggesting a history of star formation that seems far too rapid for our current understanding. These discoveries don't break the Big Bang theory itself, but they certainly stretch it. They force us to ask, is our model of the early universe incomplete? Or if these galaxies had some kind of cosmic head start, where did it come from? This is where we leave the comfortable shores of established science and venture into a truly radical idea. What if the Big Bang wasn't a beginning, but a transition? That's the core idea of conformal cyclic cosmology, or CCC, a theory from the brilliant Nobel-winning physicist Sir Roger Penrose. Penrose has long been fascinated by a deep mystery at the heart of our universe, the second law of thermodynamics. This law states that entropy or disorder always increases. The universe moves from order to chaos. It's why a hot cup of coffee cools down and a scrambled egg can never be unscrambled. The puzzle is this: if entropy always increases, then our universe must have started in a state of incredibly low entropy, a state of near-perfect order. The Big Bang wasn't chaotic. It was exquisitely, impossibly ordered. For Penrose, explaining this initial perfection is one of the biggest challenges in all of cosmology. His proposed solution is as elegant as it is mind-bending. He suggests the universe operates in infinite cycles, which he calls aeons. Each aeon begins with its own Big Bang and expands for trillions of years. This isn't a big crunch model where the universe collapses back on itself. Instead, Penrose imagines an endless series of expansions where the end of one universe becomes the beginning of the next. Picture our universe expanding forever. The stars burn out, galaxies galaxies drift apart. Over unimaginable timescales, even the supermassive black holes at the center of galaxies will evaporate into a faint bath of radiation. The universe becomes a cold, dark, and nearly empty place, filled only with massless particles like photons. And in this distant future, something remarkable happens. When mass is no longer a factor, concepts like size and distance become meaningless. A universe that has expanded to near infinity, populated only by particles with no sense of scale, starts to look mathematically identical to a universe compressed into an infinitely hot, dense point, a Big Bang. To really get this leap, we have to touch on the conformal part of the theory's name. Penrose uses a type of geometry where you can stretch or shrink distances as long as you preserve angles. Think of a photograph. You can blow it up to the size of a billboard or shrink it to a postage stamp. The objects change size, but their shapes and relationships stay the same. Penrose suggests the universe does a cosmic version of this. Once an aeon has expanded to its cold, empty, and massless end, the universe effectively forgets how big it is. At that point, a mathematical squashing, called a conformal transformation, can remap that infinitely large future onto the infinitely small point of a new Big Bang, all without breaking the laws of physics. The cold, empty future of one ion, when squashed down, becomes the hot, dense beginning of the next. This process neatly solves the entropy problem. Penrose argues that the immense entropy locked away in black holes is destroyed when they evaporate via Hawking radiation. This effectively resets the cosmic entropy clock, letting each new aeon start in that required low entropy, highly ordered state. The smooth, orderly Big Bang isn't a miracle. It's a consequence of the featureless, evaporated future of the aeon that came before it. Our beginning was written by a previous end. It's a breathtaking theory. But is it science? A theory, no matter how beautiful, is only as good as its evidence. If a universe existed before ours, could it have left any trace behind? Penrose argues that it did. The most violent events from the end of the previous aeon would be the evaporation of its supermassive black holes. While the black holes themselves are gone, Penrose calculated that the colossal energy from their final moments would be focused by that conformal squashing, punching through into our aeon as single, stupendously energetic points. He calls these Hawking points. As our own universe expanded, these primordial hotspots would have stretched out. Today, they should appear as subtle, circular patches in the cosmic microwave background, the fossil light from our own Big Bang. These patches would be slightly warmer than their surroundings, like ghosts of long-dead black holes from a lost cosmos. Penrose and his collaborators have claimed to find evidence of these hotspots in data from the WMAP and Planck satellites, identifying circular patterns with slightly higher temperatures. However, this claim is highly controversial. The broader scientific community remains deeply skeptical. Other teams have analyzed the same data and concluded that these Hawking points aren't statistically significant. They argue you'd expect to find such patterns by pure chance in any random map of the sky. The scientific consensus right now is that there is no confirmed evidence for Hawking points. Furthermore, the theory requires that all massive particles must eventually decay, which is not predicted by our current standard model of particle physics. So we're at a fascinating crossroads. In one corner, we have the standard model of cosmology, a powerful and successful theory, but one that's showing cracks at its foundation, challenged by the impossible galaxies seen by JWST. In the other, we have conformal cyclic cosmology, a profound alternative that addresses deep mysteries, but whose claimed evidence remains contested. Could our universe really be just one chapter in an endless cosmic saga? Did the ghosts of a previous universe leave their fingerprints on the afterglow of our own creation? Right now, we simply don't know. The hunt for evidence continues, pushing the boundaries of what we can observe and what we can imagine. What Roger Penrose's theory gives us, whether it's proven right or wrong, is a powerful reminder that science isn't a collection of settled facts, but a dynamic, ongoing story. It reminds us that we should always be willing to question our most fundamental assumptions. The story of the universe is still being written, and the biggest plot twists might be yet to come. What do you think? Is the Big Bang the ultimate beginning or just the turning of a page? Let us know your thoughts in the comments. If you enjoy exploring the biggest questions in the universe, make sure to subscribe and hit that notification bell so you don't miss our next journey to the frontiers of science. And for another video that challenges what we know about the cosmos, check out our episode on the Fermi paradox right here.